a coin is tossed 400 times. Use normal curve approximation to find the probability of obtaining between 185 and 211 heads inclusive. So this is a normal distribution, but this is a binomial distribution because you either get a head or a tail, and every time it's the same probability. So every condition of binomial is satisfied. However, it's prohibitive to actually use it through the binomial formula because like between 185 and 211 heads, you'll have to apply the formula 27 times. And in these kind of situations, we can use normal approximation. So remember that P, which is the probability of success, is 0.5 equals probability of getting ahead and let X be the number of heads in 400 tosses. So then N is 400 in the binomial. And we know that the mean of binomial equals NP. So that'd be 400 times 0.5 equals 200. And the standard deviation for binomial is NP times 1 minus P square root. So that would be 200 times 1 minus 0.5. So that's 100, so that's 10. Okay. And these are the mean and standard deviation, which we will use for the normal variable. So first we will change into z-score, but okay, let me write down the formula for z-score. Z is equal to x minus the mean over standard deviation. Now, what we want is probability x between 185 and 211 inclusive. Now, binomial is a discrete distribution, so we can have an integer number of heads. However, we are converting it to a normal distribution. We're using a normal approximation here, and normal distribution is continuous. So we need to apply continuity correction. So anytime we are greater than or equal to 184.5, then 184.5 rounds up to 185. So actually this in practice is, if we apply the continuity correction, we're actually having x greater than or equal to 1. So let's do it in the next line. Probability x is greater than or equal to 184.5, because greater than 184.5 will round to 185. And in this case, it would be less than or equal to 211.5. I mean, strictly speaking, we should say less than 211.5, but it doesn't matter. Now we are in the realm of continuous. So anything that's less than 211.5 is basically the next integer less than 211.5 is 211, and that's where we want to end. So we will need to change these into z-score. So z1 will be 184.5 minus the mean was 200 over 10 equals negative 1.55. And then z2 would be 211.5 minus the mean which is 200 over standard deviation, so 1.15. And we basically need probability Z is between negative 1.55 and less than 1.15. So that will be area on the left of 1.15 minus area on the left of negative 1.55. So that's area on the left of 1.15 minus the area on the left of negative 1.55 is the same as that on the right of 1.55. You can convince yourself by drawing the pictures. Area on the right of 1.55. And the table we're going to use doesn't have the right areas. We're going to use the same table that's available in the P exam. So we convert this right of 1.55 is the same as 1 minus area on the left of 1.55. Okay. So let's see. We're using the second page here. So left of 1.15. So 1.15 is here. So 0.8749 minus 1 minus now left of 1.55. So 1.55 is here, 0.9394. Okay, so let's see what this is. So 1 minus 0.9394 is 0.0606. And when we subtract this from here, that's 0.8143. Okay, let's try. Part B is exactly 207 heads. So we'll, in this case, when it's just one number, when we apply continuity correction, we look for the range of numbers that round to 207. So B, x is equal to 207. It's the same when you convert it to normal with continuity corrections. We should have written that over here also. When we said this is equal to this, so that's when we change it to normal with continuity correction. Similarly here, when you change this to normal and apply the continuity correction, you're actually saying, so the range of numbers that round to 207 are all those numbers that are greater than 206.5 or even equal to 206.5 and less than 207.5. So this range you can convince yourself rounds to 207. When you're rounding to the integer. So we need to change these into z-scores. Z1 equals 206.5 minus the mean of 200 over standard deviation. So that's negative 13.5, so negative 1.35. And then Z2 is 207.5 minus 200 over 10 equals negative 1.25. And we need probability Z between negative 1.35 and less than negative 1.25. So that's the same as probability Z is greater than 1.25 and less than equal to 1.35 by using the symmetry of the normal curve equals So area on the left of 1.35 minus area on the left of 1.25. Okay, let's see. 1.35 is 0.9115. And then 1.25 is 0.8944. Okay, so this equals 0.01671. Okay, so let's see if we did it right. 0.9115 minus 0.8944. So when I add this to it, 56 and so negative 1.35 and negative 1.25. This is fine. So it'd be between 1.25 and 1.35. Let's check the table again. 1.25 is 0.8944 and 1.35 is 0.9115. Let me just check the subtraction again. So 0.9115 minus 0.8944. That is 0.0171. So let me see what could be wrong here. Yeah, this rounding is fine. Greater than equal to 206.5 rounds to 207, and less than 207.5, that rounds to 207. And area between negative 1.35 and negative 1.25. It's the same as the area between 1.25 and 1.35. Okay. And that 0.25, 1.35. Oh, I was just doing this subtraction so incorrectly. So this is 6.5 over 10. That's 0.65. I don't know what I was thinking. I was subtracting from 220 instead of 200. And this is 7.5 over 10, so that's 0.75. So basically, it's area between 0.65 and 0.75. Z is between 0.65 and 0.75. Okay, so left of 0.75, we have 0.7734. And left of 0.65, we have 0.7422. And that is 0.0312. And then in part C, let's open a new file. In part C, fewer than 173, so you need probability X less than 173, or more than 224, so that would be addition, because fewer than 173 and greater than 224 are mutually exclusive, so you just add the or changes into simple addition. X is greater than 224. Okay, and now my continuity correction, so when we change it to normal and apply the continuity correction, so less than 173 means less than or equal to 172 for a discrete variable. So anything, so first let's think about this as less than or equal to 172, and anything less than 172.5 would be less than or equal to 172. And similarly, greater than 224 means greater than or equal to 225. So anything greater than or equal to 224.5 will be greater than or equal to 25 in the integer world. Okay, so 172.5 minus 200 over 10. So that's negative 27.5, so negative 2.75. And Z2 is 224.5 minus 200 over 10. 24.5, so that's 2.45. So you need probability. Z is greater than negative 2.75 plus probability Z is greater than or equal to 2.45. So this is equal to probability Z is less than 2.75 plus 1 minus probability Z is less than 2.45. Okay, so less than 2.75. 2.75 is 0.997 plus 1 minus 2.45 would be 0.9929. Okay, so that's 0.0071, and then you add to this one. So that's 0.0071. So 2.75 and 2.45. So that's fine. So you need, oh, I flipped this inequality. So it was going in the other direction. So it was less than 172.5. So this one would be less than. And what that would mean is probability Z is greater than 2.75. So that would be 1 minus probability Z is less than equal to 2.75 plus 1 minus probability Z is less than 2.45. Okay, so 1 minus 0.9970 plus 1 minus 0.9929. So that's 0.0030 plus 0.0071 equal to 0.0101. Okay.